Okay, now we're going to start complex rationals, and I want to just remember rationals means fractions, and complex, this means just a little bit more complicated, and that could sound scary, but it's just going to be fractions inside of fractions, okay? And so we're going to review first what it means. A fraction means to divide, so this means 1 divided by 2, okay? This means 3 divided by 4, and we're going to be dividing the fraction, so we're going to be dividing extra, okay?
Okay.
So what do we do with this fraction when we're dividing?
We do the reciprocal.
That's right. So we take 1/2 and we multiply, we change the division to a multiply, and we do the reciprocal, okay? So that's really important to remember. We're going to do that in a minute. And so then we just multiply straight across, right? So that's going to be 4 over 6, and we can reduce that. Or we could have reduced, so we had 4 over 6, right? And we could have then made that 2/3, right?
Right.
But we could have reduced before by saying 2 goes into 4 2 times, right?
Right, and so then it would have been
2/3. And so we can reduce before or after and get the answer, all right? And that's important to realize also because we can do that when we're doing letters also. We can do that, factor during or after. All right, so now this line right here, all it means is divide, okay? So we can rewrite this. This is 2/3. This means divide. This means 5 over 6, okay?
Okay.
All right? And we do the same thing we just did before. So this line here, these lines of fractions, all they mean is divide. So then I just keep my 2/3 the same. I multiply by what?
6 over 5.
Good. And then I can reduce now or later. So I can say 3 goes into 6 twice,
So
and so I'll have 4
4
over 5, and I have that one done. Okay?
Oh, this
Not
is
so bad at all.
not hard.
We're going to add some letters now. Okay, so we do the same thing. This line here, and they usually tend to put a little longer so that you can actually visually see this is a fraction on top and this is a fraction on bottom. Okay, so this means a over b to the third divided by a squared and 2b. Does that make
So we
sense?
do the reciprocal.
That's right. So we have a over b cubed times the reciprocal. We put a 2 on top, the 2b, and the a cubed here. We could, excuse me, that was a squared. We could just multiply it all out and reduce it, or we can reduce it now. Which one do you want to do?
Reduce it now.
Okay, so I'm going to actually change colors so we can see a little better. Okay, so the I have the a's here, and I have 1 here and 2 here, so that'll go away.
That'll become an... Okay, oh yeah.
And that'll just become a 1, right?
Right.
And then I have a b here, and this is going to become a squared. Okay, let me get back to the color we can see better. All right, so now we have 1 here times 2 here, so it's just going to be a 2.
And then we'll have b squared a.
B squared and a. All right, so
Okay.
b squared.
That's
That's not too bad, right?
No.
So far, so good. We're just going to take the denominator, and if eventually you might be able to skip this step and just take this one here and flip this one to put it there.
Oh,
Okay,
okay. Yeah.
if you can. But if you can't, it's not a problem to write it out. Some people just need that middle step to see everything. So if you don't, if you need this step here, just write it. It's not a big deal. Okay. Okay, now we're going to get a little more. These are getting what they call them complex. So, but the same rule applies. This is a divide. So I'm going to take that x squared minus 9 over x, and I'm going to divide it.
Can't we make it to x minus 3x plus 3?
Yes, we can. So we could do that now if you want. This is going to be x minus 3 and x plus 3 over x. I'm going to take...
Oh, and so then x plus, or x to the third, and then x minus 3 on the bottom.
Yes,
So
we're
it'll
flipping
cancel.
this. Good. Okay, so we flipped this. That's how we got here.
Okay, so this will become x squared.
This is going to come... I'm going to get a better color than I did last time. Okay, so this one is going to become a squared, right?
And then this will cancel with that.
That cancels with that.
So then when you rewrite it, it'll be x plus 3, open parentheses, close parentheses, and then x squared at the end.
Yes, we can put it here or here.
Or at the beginning, yeah.
I'm going to put it here.
I like it at the beginning, too.
Yes, and then the no denominator at all. We got it. Okay, so we still same concept. This is just a little bit more compacted of a writing, and you just need to understand. Mathematicians don't use words; they use symbols to say what they're meaning. And so this line in the middle right there just means we're dividing.
Okay.
All right. So there's going to be a different method they're going to have us use also. And just depending on the problem can help us. Okay, so this time we're going to have like 2 fractions dividing another fraction. So we're going to leave this 5/6 here. And we're going to divide all this by 2 over 3. Okay?
Okay.
All right? They suggest that this looks a little bit too cumbersome to do, and they're going to suggest us to do something else. So instead of
good.
this, we're going to, since we're adding these things together, what they're going to have us do is find the common denominator of 6, 5, and 3. What is the common denominator for that?
30.
30. So they're going to suggest that we actually take this thing and multiply by 30, and take this thing and multiply by 30. If you remember, we did this when we were solving equations, and we had fractions, and then we multiplied everything by the common denominator. That's going to help us in a similar way.
Okay.
When we do that, this 30 is going to multiply in here, and the 6 and the 30 are going to cancel and become a 5.
Okay.
So we'll have a 5 times that 5, which will be 25. Does that make sense?
Uh-huh.
Okay. And I need to come take this stuff out now. Okay. This 30 again is going to distribute right there.
So it'll become 18.
Yes, because this 5 and the 30 are going to reduce to 10, right? And we're going to have a 10 times 3, which is minus a 30.
Okay.
You with me so far?
Yes.
Okay. So then, we're done with that. We distributed this 30.
So then this will become a 20 because you'll take the 30 and the 3 will reduce to 10, and then times 2 is 20.
Very good. So we'll take this 3 and it'll reduce to 10, and we'll have this teeny little 10 in there, and 10 times 2 will be
20.
20. We'll have a 20 there. Look at that. Compared to what we had, now what we have is super nice.
Yeah.
So what is the 25 minus the 30?
5 over 20. Oh, and then we can reduce that to 1 over 4.
Very good.
Okay.
Okay. So this one wouldn't have worked well to do that common denominator thing.
Yeah.
We could have, but it wouldn't have worked as well as this one. Okay. So they're going to have us do that the same thing here, but we're going to actually find that common denominator to do that with. And the nice thing is, because we have the 1s here, we're going to rewrite that as 1 over 1 plus 2 over x. That kind of helps us to see that they're both denominators there. Or I could do this. Okay.
Okay.
All right. Ooh. Okay. So they're going to want us to say the common denominator of a 1 and x and y. What is the common denominator?
1. Well, no, wait, there is no common besides 1.
What do they don't have anything in common. Just like back here, the 6, the 5, and the 3, we didn't multiply all of them together, but there was a factor in common with the 6 and the 3, which was the 6, right? So we could just take the 6 and the 5. There's no common thing between x and y and 1, so we just multiply them all together.
Oh, okay.
And the common denominator is xy. We're going to multiply the top by xy and the bottom by xy. Okay?
Okay.
And when we do that, we're going to, I don't know what this is happened there. Okay, so this we're going to multiply by xy, and this we're going to multiply by the xy. We'll do that same thing, but distributing it. Okay, so when we distribute it here, nothing will cancel.
Right, so it will just become
xy. Okay, xy.
And then plus 2
Now this
will cancel.
will cancel. When they do this, these x's will cancel.
So
It'll leave me just a y times 2, which is a 2y.
okay.
Okay,
So then on the bottom, nothing will cancel again. So it'll be xy,
yes, xy.
and so then it'll be plus 5x.
Because this time, the y's will cancel on that, leave you with that 5 times the 5x, right?
Right.
Okay.
Okay.
All right, are we done?
No.
No, let's try to factor this to see if we can get anything to cancel. On this top thing, can something factor out? Is there something in both of them?
Y.
Okay,
So
so-
we can do a y and then x plus 2.
Okay.
Then on the bottom, we can take an x out of both. And y plus 5.
Is there anything that cancels? No. It's a good thing to factor it anyway, just to make sure. Okay.
Right.
All right. This one was a little harder because we had to find the common denominator. And if you don't know what the common denominator is, just multiply everything together.
Okay.
It is going to make you have to reduce more at the end. But if you don't know what it is, you can't just quit. Just multiply it all together.
Okay.
All right. And so we have just did complex rationals. We just started out and told you what it looked like when you saw it in 5th grade or whenever you learned how to divide for your fractions. Okay? And then we just turned it into a new way of looking at it. We just said that this means divide, and we flipped it like we did before, did the reciprocal and multiplied. Did the same thing, but we did letters this time. We multiplied by the reciprocal. This time we did the same thing. We just had letters and multiplied by the reciprocal. And we had a little more complicated where we had to factor. This last 2, we did a new method where we actually multiplied by the common denominator. And it made it simpler when we were done with that so that we could reduce it down. This time we didn't flip it. We didn't do the multiply by the reciprocal at all.
Right.
We could have, but we didn't. Okay. This one we did the same thing. We had 2 fractions. We were adding fractions in there, and so we multiplied by the common denominator, and then we did the stuff after that. Okay?
All right.
Okay?